This is the start of Chapter 3, all about expressions. 3.1 is about algebraic expressions. So we have something called like terms, and these are terms that have the same variable raised to the same exponent. If both of those are not the same, they are not like terms. If they are constant terms, they are like terms, because they all have the same variable of not having any variable. So they do not have variables, they are plain numbers. So we are going to identify the terms and like terms of each expression. Terms are separated by adding or subtracting, so we can rewrite all the subtracting to be adding a negative. And here I have 3x minus 5 plus 13 minus x. And we know that subtracting is the same as adding a negative. So if I switch all of these to 3x plus a negative 5 plus 13 plus a negative x, these plus signs separate all of my terms. So if I identify the terms, anywhere that there is a plus sign becomes a comma to separate my four terms. Then the like terms, I have some of them have x's and some of them do not. So 3x and negative x are like terms because they have the same variable, and negative 5 and 13 are like terms because they are both constants, and we know that constant terms are like terms. Over here I have k squared plus 9k minus 2k plus k, and this one, they're all k's, but they are not all like terms. So I'm going to rewrite it to add the negative so that I can easily list out all four terms here. And then the like terms, I have a k squared and a k, but we said that they have to have the same variable, which they do, but raised to the same exponent. And so this has a k to the power of 2, and this has a k to the power of 1. It's an invisible 1 there. Since they have different exponents, these two are not like terms. So our like terms are k squared and negative 2k squared, and then 9k and 1k. So just be aware of the exponents when they have the same letter. If we have simplest form, this is where we have an algebraic expression where it has no like terms and no parentheses, meaning I have combined all of the like terms together, adding or subtracting them, and then I have multiplied anything that has parentheses. And we can combine like terms by using the distributive property. We're going to look more at the distributive property in 3.3 to add or subtract their coefficients. So the coefficient is the number in front of the variable, and this makes a difference in how many x's there are or whatever variable we have. So if I'm going to simplify 3x minus 12x, then they both have an x, so I'm going to put this on the outside, and then I can do 3 minus 12, which is negative 9. We could rewrite this like we did in Chapter 1 to have 12 minus 3, and then the answer takes the sign of the larger number to be negative 9x. Over here, I have negative 2.5y plus 8.2y plus y. If there is just a variable and there is no written number in front of it, it has an invisible 1 as its coefficient. So here I have negative 2.5 plus 8.2, and I can, since they have different signs, we are going to subtract to get 5.7. So then this is 5.7y plus 1y to make 6.7y. If I have negative 12x plus 20x, then this is 12 minus 20x. We can reorder them using the commutative property, and 12 minus 20 is 8. I have 3/8z minus 1/4 z, and we need to rewrite them so that they have a common denominator of 8. So 3/8 minus 2/8 is 1/8 z. It is important to note that if terms do not have the same variable raised to the same exponents, they are not like terms and cannot be added or subtracted. So we are going to simplify a few things. Here I have 3/4 x plus 7 minus 3 over 2x minus 2. I'm going to reorder these so that my like terms are together. It makes it a little bit easier to add or subtract. So 3/4 x minus 3 over 2x, these need to have common denominators. But I can also do 7 minus 2, which is 5. So then 3/4 x minus 6 over 4, multiplying these each by 2, will give negative 3/4 x plus 5. 3 plus a negative 6, 3 minus 6 is negative 3. I have 15 minus 5x plus 6 plus x. Rewrite these so that my like terms are together. 15 plus 6 minus 5x plus 1x. 5 minus 1 is 4, but the 5 is the larger number, so I get negative 4 to get 21 minus 4x. For now, the order does not matter. We will get into it later when we need to have the order written in a specific way. Here we have each person in a group buys an evening ticket, a medium drink, and a large popcorn. How much does the group pay when there are 4 people in the group? So we are given how much all of these prices are, and everybody buys an evening ticket for $8.50, a medium drink for $3.25, and a large popcorn for $4.50. And since we need to make a little equation, we have the number of tickets multiplied by the cost of the tickets, added to the number of drinks multiplied by the cost of the drink. We have the number of popcorns that we buy multiplied by the cost of the popcorn that each one is. And since each person is buying the same thing, and we have 4 people in the group, each of these 3 numbers are all going to be 4 for the 4 people. So I have $8.50 times however many people, plus $3.25 times how many people, plus $4.50 times that same number of people. So I can add all of their coefficients together to get $16.25. And then it said that there are 4 people in the group, so I'm going to take $16.25 and multiply by how many people there are, and doing that math is going to give $65 total for the group.